In the previous video, we saw that when charged particles move in electric field across some voltage difference or potential difference, then they either lose potential energy or gain P, and this change is then reflected in the either loss or gain in the kinetic energy. When we are dealing with charged particles, the amount of energy is really small. For example, if we look at an electron which moves across a voltage difference of 100 volt, then there is change in delta P is equals to Q times delta V, which is equals to 1.6 times 10 to the minus 19 times 100, and that comes out as 1.6 times 10 to the minus 17 joule. Now this energy level, and that's not only with respect to electron but all charged particles, this energy is extremely small. So we need a new and convenient unit, and the convenient unit is basically electron volt. We call it electron volt. So electron volt is a unit of energy. And what is this equal to? Electron volt, let me write it here, I think that will be better. 1 electron volt is equal to delta P, or for that matter delta K, when an electron, or for that matter or proton, which because both have same charges, 1 unit of charge, when electron or proton moves in an electric field across a potential difference of 1 volt. So first we can find out how much 1 electron volt is equal to, because this 1 electron volt is equals to the change in P or K when electron moves by 1 volt. So this change is equals to basically Q delta V, which is equal to 1.6 times 10 to the minus 19 times 1, and that many joules. So this is basically your 1 electron volt. Very important. And electron volt is a very convenient unit, because when we are talking about electron or proton, for example, then we don't need to worry about the charge. We can just convert voltage difference into electron volt. For example, electron moving across 200 volt, then delta P is equals to 200 electron volt. Likewise, proton moving across 300 volt, then we have delta P is equals to 300 electron volt. And final example, alpha particle, which is basically a helium nucleus. So basically we write it like this, 4,2, which means it has a charge of +2 there, moving across 500 volt, which means that delta P here is equals to, because charge is 2 times 500, so it is 1000 electron volt. Very convenient. And this unit is normally used when we are dealing with particles. Okay, let's look at an example here. A proton is accelerated from rest by a potential difference of 50,000 volt. Find its K in electron volt as well as in joules. So we already know that delta P is equals to, we don't need to do anything, this is 50,000 volts, so delta P is equals to 50,000 electron volt. And we can be more specific here. We have written delta P, but we need to be specific whether it's gain or loss. So we see that proton is accelerated, which means that its kinetic energy is being gained, right? So we can say that this is kinetic energy is gained, so this is loss of P here. Loss of P happens here. It's kinetic energy, so kinetic energy is equals to same thing, 50,000 electron volt, and it can be converted into joules now. 50,000 we already know that 1 electron volt is equals to 1.6 times 10 to the minus 19 joules. So 1.6 times 10 to the power minus 19 joule, and this we can readily write as 8.0 times 10 to the power minus 15 joule. Now this is the kinetic energy of the proton now. So we can find the velocity as well. So kinetic energy, we know that it is equals to K is equals to half m v square is equals to 8 times 10 to the minus 15 joule. Substituting the values, we get v is equals to square root of 2 times 8 times 10 to the minus 15 divided by m of proton comes here. It will come here. Let me just write it here. So 2 times 8 to the power 10, 8 times 10 to the minus 15 divided by m. Mass of electron is 673 times 10 to the minus 27 kilogram, and that gives me a velocity of 3092516.47 meter per second. And these kind of questions are really popular and very important from the point of view exams and tests. Okay, another type of question that we have next we're going to look at is this. An electron is fired into a uniform electric field strength this between two parallel plates with a velocity of this. So I can probably draw the diagram here in the same direction as the field. So electric field is in this direction, which means we got a positive plate here and negative plate here. So electron is being launched from here. All right, and this electron is being launched with a speed of 5200 meter per second, and this electric field is 200 Newton per Coulomb, and the distance between them is 5 centimeters. All right, so what is happening is that we need to find out whether the electron would reach the opposite plate or not. So here we need to think what's happening here. This electron, when it gets closer, as it gets closer to the negative plate, it slows down, which means its kinetic energy reduces. And where does the kinetic energy goes? This kinetic energy goes into increasing its potential energy. So first we need to see if an electron moves from here to here, this point, from A to B, what would happen? Whether electron would gain P or lose P. We already know that because it will be repelled by the negative plate, so it will lose the kinetic energy. It means it will gain P. And how much P it would gain? It would gain P equals to voltage difference between positive plate and negative plate. That's what we need. This will be the gain in P. Now we know the charge of the electron, but we don't know the delta V here. So what we are given? We are given that electric field between the plates is 200 Newton per Coulomb. The distance between the two plates is 5 centimeters, which is equals to 0.05 meters. And using this, we can find out delta V. We have the formula E is equals to delta V over D, which tells you that delta V is equals to E times D. Substitute E there. Substituting values. So got 200 times D is equals to 0.05, and that give me a voltage of 10 volt. This is the voltage difference between positive plate and negative plate. Now we can find out how much will be the gain in P of the electron if it reaches the opposite plate. So 2 to reach the opposite plate, electron will need to gain P equals to Q delta V, which is equals to 1.6 times 10 to the minus 19, that charge of electron, times 10 volt, which gives you 1.6 times 10 to the minus 18 joule. So if the electron reaches the opposite plate, it will gain that much energy. And where would that energy come from? We already know that this energy has to come from the kinetic energy. So all we need to do is we need to see whether electron has sufficient kinetic energy which can be converted into this P. So electron's kinetic energy at point A should be enough to give a gain in P of this much. Yeah, as electron goes from A to B, here it will lose that Ke, and if it reaches point B, then it will need to have at least this much kinetic energy. So initial kinetic, let's see how much kinetic energy it has. In this initial Ke is equals to half mv square, half time, that's the mass of electron, and velocity is given as 5200 square, and this comes out to be 1.232 times 10 to the power minus 23 joule. And this is not enough. This is very small in comparison to what actually is needed. So we can see that electron does not have enough kinetic energy to reach the opposite plate.